Okay, now we're recording for Michael. Being very serious. Poor Michael, you don't know the craziness you're missing. Actually, poor Michael, because he has to watch like 12 of these videos.
And I vote we do 27.
It's just Morgan.
We don't do 28. It's multiple of 3. Come on.
So 21 and 27.
I think 21 and 27 are the ones that we pick.
Okay.
Just me and Izzy, but no one else.
Yeah. Morgan's very decisive. And Izzy is questioning whether other people would like number 21 and 27.
They said nothing.
I am
I'm just kidding.
scared of going against Morgan.
Okay.
Hey Morgan, look at me right now. Look at me right in the face. Hey, everybody in the back row, do you want to go with Morgan's opinion? Okay, let's do it. Some frightened faces back there, Morgan.
That's not fun.
All right, so number 21. Oh, you're gonna be. I cannot. You know what I really hope, Morgan? I hope you end up in some sort of like CEO position in some company where you just like destroy businessmen on a daily. Like I want it to be so badly. You're gonna walk in a room and some guy's gonna be like, I think we should, and you're gonna be like, no, and then I'll be like, yeah, get him, you get him, Morgan. And they'll be like, women can't make decisions. She'll be like, women can't what? And they'll be like, yes, get in there. Sorry, Michael. She's gonna be awesome. Okay, so let's talk about what A, B, C, and D mean on these. Okay. All right. Plus, I'm gonna write plus 0 and plus 0 out here just so that I have an A, B, C, and D. Okay. A, B, C, and D. Now there are some things that do change, not much, from cosine and sine graphs. A is what? Amplitude. And all that's going to do, so if A is bigger than 1, it is going to make it like steeper than it normally is. It's almost, so you know how it looks kind of like a S, right? Kind of like a backwards S. Imagine if I took the edges of those S and kind of pulled them tight so they'd almost go a little bit steeper up, okay? And if it's less than 1, and by less than 1, I mean like between 0 and 1, that's a flatter line. So instead of going like this and curving out like that, it more really kind of lays down before it curves up a little bit more. And you don't have to be specific about it. Just make it sure that it looks a little flatter, a little steeper, that kind of thing. And if you're worried, like if you're taking a test and you're worried, this doesn't look flat enough, write flat next to it, and I'll be like, they got it. You know, like, it doesn't need to be perfect. I mean, like, we're not going for perfect curves. Is that right, Sierra? Doesn't have to be a perfect curve. Could be points. Could be points. Who's to say? How about a negative A? What's a negative A do? Changes the direction, same as before. So negative A changes direction. The only things that are different about what A, B, C, and D do is that A changes a little bit, and then also the period changes a little bit. You know how the period is normally 2 pi divided by B? What do you think it's this time? What was the period on tangent and cotangent graphs? Pi, so it's pi divided by B. Everything else is the same. Okay? All right, so if we look at a tangent graph compared to a cotangent graph, a tangent graph normally looks like it starts at 0, kind of goes up, and its first asymptote is at pi over 2. So on this one, I'm going to draw my picture. We're drawing 1 period or 2 periods, whatever you want. All right, so my amplitude for this one is -2. That means it's going to be a little steeper than it normally would be. And my period is going to be pi divided by 1/4, right? Which is the same thing as what? pi times 4, which is 4 pi. Okay. So now normally, if you look at a tangent graph, there's my tangent graph I made yesterday. If you look at a tangent graph, it looks like this from 0 to pi. Now it's going to look like that from 0 to 4 pi. And things aren't going to move at all. So why don't we go from here to, it's hard to decide. Let's just go from here to here. You guys okay with that? Okay. So normally 0 to pi, that would be 1 period. I guess we could go backwards like that, but 0 to pi is 1 period. So I'm going to go 0 to 4 pi instead now. And you actually only need 2 tallies for this instead of 4, which is very nice. On all of them. Well, I mean, when it's moved to this way, instead of it being 0, it might be 3 tallies, right, with that beginning tally, but you won't need 4 sections, just 2 sections with those 3 marks. Okay, where is the asymptote usually for a tangent graph? Pi over 2, or as Izzy says, pi over 2. It's fine. Pi over 2 is where the asymptote usually is, but it's halfway, right, between 0 and pi. Do you guys see that? So what's halfway between 0 and 4 pi? 2 pi. Okay. All right, so I'm going to draw in my asymptote right here. I know that this graph is going through 0 here and here. Now, normally, this graph looks like this, kind of like going up in this spirally kind of pattern, bottom left to top right, but now it's a -2, so how should I change the way this looks? Top left to bottom right, that's the negative part. What about the 2 part? When A gets above 2, what happens? It gets steeper. Okay, so we're almost going up, like way up here. Let's see how this is doing that. Instead of laying down a little bit like this, do you see how mine is steeper than this picture? Do you understand what I mean by steeper? Okay, there's like 10 of you in here, and 5 of you, when I said, do you know what I mean by steeper, literally didn't change your faces slightly at all. Do you not know, or you're good? You good? Do you need help, Zach? You don't know what a tangent graph looks like. You're just learning this all for the first time. Okay, all right, absorb. We'll get there. Okay. So this is basically the asymptote, then there'd be another asymptote over there. And that's it. These ones are going to be easier than the sine and cosine ones. There's going to be no problems that were assigned where you change all 4 things at once. Okay? All right, what's the other one you want to do? 27? Is y equals cotangent 3x plus pi over 4. Okay. All right, amplitude for this one. 1, which means it's going to look about normal, about like the picture that you drew. How about the period? How do I figure out the period? Right, pi over 3. Okay, how about that? How far is it moving left and right? The phase shift. It is moving left. Not pi over 4. Do you remember how to find the phase shift? It's C divided by B. So we've got to take pi over 4 divided by 3, which is actually pi over 12. Okay, so pi over 4 divided by 3 over 1 is the same thing as pi over 4 times 1 over 3. Nope. Period would be 2 pi divided by b or pi divided by b in this one. So the left-right movement is the c divided by b.